Say for example, I have a class, okay, and in this class I might have some method called m1 or right? And now I'll call this as my parent class. Okay, this is my parent class, and I do have another class which is my child class, which is extending this child parent class, right? And can I have the same method here in the child class? Can I have something like this? We have understood overloading concept. If you remember, we have understood method overloading concept, where we can have the same method name, but it has to differ in either number of parameters or different data types to the parameters. We can have the same number of parameters, but the data type of the parameters has to differ, or at least the order of the parameters has to differ. So that's how we have defined the method overloading. Now we are saying everything as same, the signature. So parent and child class, everything as same. So we do have parent class, and child class is inheriting parent class. And I do have a method called m1 in parent, and I'm defining the same method in child class as well. Child class itself will have a copy of m1 in parent, as child class is extending or inheriting the parent class. We know this. We understood in the last session as part of the inheritance concept. Now, what we are doing, we are trying to define the same m1 method with the same signature as well. So the return type is not we don't consider return type in method overloading. So the method name, the number of parameters it takes, everything like order, data type of the parameters, everything exactly the same. If we have the same signature, can we do like that? In method overloading, we can't do like that. It just says it's a duplicate. So why we are defining in M1 in child? Because anyway child is extending parent. So we'll have a M1 method here in child, right? So method we'll already have in the child. And again, if I wanted to have another method called M1 here, that is also possible. That's also possible. And that is what we call it as overriding. So we provide a specific implementation for the method. So we'll have some default behavior here, but what do we do here is like we'll have some default behavior in the parent class. So any child class which is inheriting this parent class will get this method with the default implementation. But in child class, we wanted to override this method, maybe to add something more, or we wanted to change the whole implementation of that method. And that is possible, and that is what we call it as overriding. Overriding in overriding in Java, right? That is what we call it as method overriding. So when a subclass provides a specific implementation for a method that is already present in its superclass, is called as overriding. So when a subclass provides a specific implementation for a method that is already defined in superclass is called, this is specifically method overriding, right? So we will have one method and we wanted to have the same method with the same signature. We can have it and we can override the child class method. Meaning, so whenever we wanted to access this method, then using the child object, so it will be a conflict, right? So which method has to be selected? So in that case, we can select by default, like child class method will be selected, as both the methods will have the same signature. Yeah, it seems to be similar to the method overloading concept, but we'll come to that. First, we'll understand what method overriding is, and then we'll see the differences between method overloading and method overriding. So let us first understand method overriding with an example. I'm creating a new package. We'll call this as stage 15. We'll just an overriding demo. Let's say, for example, I have something called my parent class is bank, and just for simplicity, we'll take one method, rate of interest. So this is a method which returns rate of interest. So we'll just say something like this. By default, it returns 0.5, right? So that's my parent class. And we are gonna have one child class, which is extending the bank class. Again, I wanted to have the same method here. So is that possible? So it says return statement, but yeah, we can return some statement here. But if you observe, both ROI, right? So when I say extend bank, what happens? This method so is accessible by uh, this method, this class, right? So this method ROI, which is declared and defined in bank, right? In bank class. So as JPMC class is extending bank class, so it will have a copy of this, or it can access this method which is defined in bank class as it is extending or inheriting bank class. But what we are doing, we are taking the same signature. If you see, even the return type is also same. So though return type doesn't matter for method overloading, so we are defining the same signature. So a method with same name, and in this case, which is not taking any parameters, exactly the same signature. And we are defining, or we are providing body to it, or providing specific implementation to it, right? So we don't want it to use the implementation which is defined in the already defined in the parent class, but we wanted to provide our own implementation. So what we did, we actually had the same signature of the method, but implementation or the body, that is the contents within the method, we have actually changed. So this is what we call it as method overriding. And you can see there is no syntactical error, right? So there is no compile time error because this is what we call it as method overriding and is supported by Java. Say for example, I do have some other class, another class. So again, this is also extending the same bank class. So under which inheritance type this comes? So I have two classes. I have a class, parent class, and I'm having two child classes inheriting the same parent. So under so which type of inheritance is this? So this is called as hierarchical inheritance. This we have discussed in the last session, right? So hierarchical inheritance. So having one parent and more than one child inheriting the same parent, right? So we have discussed this. One child inheriting, so multiple childs inheriting same parent, right? This is the concept of hierarchical inheritance. Now, if you see here, we have bank class parent and we do have two child classes which are inheriting the same parent class. And what did we do here? Something special, right? So we are overriding the method. The method has already been defined and implemented in a parent class. But with the same signature, we are having another method in child class and overriding the implementation of that method. Now, let us actually create objects for these child classes. Let's call it. Now, when we say like this, JPMC object for JPMC class has been created. All right. Now, when we try to call the method ROI, so JPMC will already have the copy of this bank class, right? And it has JPMC has its own method as well. So there are two methods if you observe, right? As JPMC is extending. But when we call JPMC.ROA, so which method will be taken precedence is, so the method where we are, providing the specific implementation for that class, right? So that will be called, meaning the method which we define within the child class, which is overriding the superclass method, right? So that will be called. See, we can see. So if this was written, we would have got the output as 0.5, but we got an output as 9.81. So saying that, you know, it actually called the child class method, right? So in the same way, we can have it for other class as well, other child class. In this case, it should call the child class method again. Yeah, we can clearly see that. So even though we have a method defined in parent class, as we are overriding its method implementation, so and when we create an object for the child class and try to access the method, so even though both the child classes like are extending the parent class, so the method, the method which has been overridden in that class, child class will be called, right? So this is what we call it as method overriding. Is is that clear? Simple concept. So we might have already have some definition, but in the parent class for one of the methods, for one or more methods, but when we are wanted to have our own implementation in the in the class, right, in the child class, then we can override that method. We can override that method in the child class. So that's all about the method overriding. Hope it is clear. All right. Now, am I audible? Okay. All right. So now we'll see. So this is overriding concept, right? Now we will understand, the differences between method overloading and method overriding, right? So we already know method overloading, right? So which will have the same method name. So method overloading is all about having the same method name and having a different parameter set, right? So and overriding having the same signature, but yeah, same signature, right? That we understood. Now we'll understand with an example like overloading and overriding. Overloading versus overriding. Say for example, I have some class called ABC, and we do have some method called M1 which takes a parameter integer. So this is one class, right? And say for example, we do have another method which takes same integer parameter. All right. So this is one class. Now we'll have one child class. I will just call it as XYZ, and which is extending ABC class. Now what I wanted to do, I wanted to override this method M1, which is already there in the my parent class. So this is my child class, right? XYZ. So I'm having the same signature, and I'm just having overriding this method. Overriding just to display A plus A, right? Or maybe A into A, something like that. So this becomes overriding, right? So I already have the method defined in my parent class, and I'm having the same method again with the same signature, right? So then that becomes method overriding, right? So this becomes overriding. So in the same way, like I wanted to have M2 as well, M2 defined, where we'll have the different implementation, right? So even this becomes overriding. This is also overriding, right? All right. Now, what is overloading? I can have same M2 defined here, but I'll have a different parameter list, right? So see, I'm showing difference in parameters in the number of parameters I have in my method, right? So I'm having the same method name, but in the earlier method we had only one parameter. Now we are having two parameters. This method is accepting two parameters, and we can say this is method overloading by just looking at the method name. Method names are same, but the number of parameters are different. So this is method overloading. And if you observe, for method overloading, we can have it in one class itself, right? So in one class we can achieve method overloading, but method overriding comes into place when we do have at least two classes, right? So we need to have the parent class and child class definitely because so method overriding, when does we can achieve that? When we extend a parent class, so child class gets a copy of parent class, right? And when we wanted to have a specific implementation of the method which is already present, right? Which is already present in parent class, then we do have the same method signature, and we can change the implementation of it. Implementation is nothing but the body of the method. So this we call it as declaration or definition, and the implementation or body of this method is the content within the method which we are writing, or the block of code which we write within the method, that we call it as implementation, right? So that can be changed. So in order to change that, we'll have the method overridden in the child class. That's called overriding. And in order to achieve that, we definitely need two classes. So multiple classes, at least two classes, right? So that is called overriding. And overloading, we can achieve it in the same class even. So in the same class also, we can have one single class and we can achieve method overloading. So you can see it here, right? So M2 is defined within the same class, and we are able to achieve method overloading within the same class. So that's one difference. And you can clearly see this overriding and overloading here, right? So this is a simple example to understand it. Now, what do we usually do? It's a child, XYZ is a child class, right? So we'll create an object for XYZ object. We'll create an object for this. Object dot. When I say M1, so it has to call M1 method of XYZ, right? Because it has been overridden. The method M1 in the type XYZ is not applicable to the arguments. Okay, we have to pass an argument to it, right? So we can pass an argument. M2. So whatever we wanted to pass, we can pass it here. And XYZ dot obj dot M2, we can have single parameter sent as well, right? So as M2 has two definitions. So M2 has been overloaded. So we can have like this, right? We can call the same M2 method, but with a different parameter sent. So this will become method overloading. But if you observe, this becomes overriding. So let's execute this and verify. Yeah, you can see. So if it would have called the parent class, right? So it would have written 5 directly, right? But it is written 25, meaning it is written 5 into 5. It has taken the implementation of child class method, right? So that's called overriding. And you can see the other types as well. M2, when we pass it 10, 20, so this method was called. So we do have two methods matching M2, but it picked up this M2, which is accepting two parameters, two integer parameters, right? And last one is M2, like it actually identifies M2 to be called, which takes one integer parameter, and it is just doing the product of it, right? So this is all about overriding and overloading. So we can even see some of the differences here itself, right? So we can achieve overloading in one class, single class itself. But to achieve method overriding, we need at least two classes, right? So that's one difference. And also in the signature, right? Only similarity will be method name. And also, yeah, if you see the difference, so the signature for method overriding, it has to be the same, but overloading, it should have different signature of the method. So we'll see that now. So these are all the differences between, we are understanding differences between overloading and overriding. Very important interview question again. So what is the difference between method overloading and method overriding? So method overloading, so we do have we can have it in the same class. Methods must be in the same class or in a superclass and a subclass as well, right? As when we extend or inherit, the methods can also be seen in the subclass. So in that case, we can achieve the method overloading in different classes as well. But usually we can have it in the same class as well, single class as well. So that's about method overloading. And method overriding, we definitely need one subclass and one superclass, right? So it involves superclass as well as subclass, because once we define a method in superclass, only then we can override it in the subclass after inheriting it, right? So it involves definitely one subclass and one superclass at least, method overriding, right? Second one, it takes different parameters. So methods must have different parameter list in overloading. So that we have seen, right? But in method overriding, it has to have the same parameter list in the same parameter list, and also the same order as well, right? Methods must have the same parameter list and also the same order. So but overloading supports only different parameters for the methods, right? And yeah, and coming to overloading, the next difference is compile time polymorphism. So which we call it as static binding as well. So method calls are resolved at compile time. So we define the method overloading. For method overloading, we can have the same method name with different parameter list, right? So we do have multiple methods now. And when will this be resolved? Resolved in the sense, compiler should determine which method has to call. As we have the same method name, we have different methods, right? So it will be resolved at the compile time itself. So how compiler differentiates the methods is using the method signature. Based on the number, type, and order of parameters, it actually knows or determines which method has to be called during the compile time itself, right? So when we are writing the program itself, so during the compile time itself, it actually determines. So JVM actually it knows, compiler, it knows which method has to be called, right? That's called compile time polymorphism, which is also called as static binding. You should not get confused when uh, when you get a new term called static binding. So static binding refers to compile time polymorphism, and compile time polymorphism is related to method overloading, because compiler knows which method to call during the compile time itself, right? So that's the reason it's called compile time polymorphism. And coming to method overriding, it's a runtime polymorphism. It's also called as dynamic binding. So method calls are resolved at runtime. That is, JVM determines which method to call based on the actual object reference variable points to at the runtime. So we have seen this, right? So it actually doesn't know till the point you create this, till the point we create the object and call this method. So once, so when will this object gets created? Only when we run the program, so an object for this class gets created, and after created, we get the object reference, and using the object reference, we are calling the method, right? So this JVM only knows during the runtime. So when we run the program, only at that time it knows which method has to be called in the method overriding, right? So that's the reason it is called as it is known only at runtime. When we run the program, it is called as runtime polymorphism, also known as dynamic binding. Also known as dynamic binding. And coming to the next difference, return time. method overloading, so the return type can be same or different, right? So it doesn't matter, right? In the method overloading, so we have seen like we can have void, int, any other return type, but that doesn't matter in the method overloading. So when we overload the method, we can have the same return type or a different return type. So that is not considered for method overloading. Only parameter list, right? So parameter, that too, the number of parameters, the type of the parameters, and order of parameters matters in method overloading. Whereas coming to overriding, the return type must be the same. So the return type must be the same for the methods. So if I have a method with one signature, one return type, and some parameter list, I should be having the same return type and same parameter list in the child class as well. Only then we call that as a method overriding, right? So the return type must be the same in method overriding. And method overloading is applicable to polymorphism. So it is applicable to polymorphism, right? So polymorphism is one thing taking multiple forms, right? So that is applicable to polymorphism. It is also applicable to inheritance when we do, when we extend the class, when we inherit the parent class to child class, so we get the methods in child class. So we can actually have another method which overloads the existing method in the parent class. So that's the reason. So indirectly it supports inheritance as well. It is applicable to inheritance as well. But coming to overriding, it is applicable purely to inheritance. Because overriding, the concept itself is like, it allows subclass, right? It allows subclass to override the superclass method. So when do we get this subclass and superclass concept? Only in inheritance, right? So it is applicable to only inheritance. And the purpose. So it provides multiple ways to perform a similar operation. We have seen an example, right? A calculator example where we actually overloaded the addition method, right? So we can pass two parameters, it adds. You can pass three parameters, we can have a separate method defined for it, and it adds three methods. So using the same method name, we were able to have different similar operations called addition, right? So that's the meaning of it. It provides multiple ways to perform a similar operation. And overriding, so it allows a subclass to provide a specific implementation for that method. So this method, which is already defined in a superclass. So we do have a method in superclass or parent class. And as we are inheriting the class, child class is inheriting the parent class. So the same method will be present in the child class as well. But we wanted to override the method because we wanted to provide a specific implementation. Only then we do overriding, right? So that's the main purpose of method overriding. So these are the differences between method overloading and method overriding. And coming to similarity, only similarity is method name, right? So method name, only method name is same. That's the only similarity between method overloading and method overriding. So this is all about differences between method overloading and overriding. Is it clear, everyone? Okay. Now we'll learn one keyword, one new keyword. Super. Super is a keyword. So coming back to the same example, right? So now, whenever I create an object for XYZ, right? So we know this is overriding, right? So M1, XYZ object are M1. So whenever I create an object for the child class and call the object M1, so always the child class method takes precedence and because it has been overridden, and this will be called, right? So this will be invoked. But what if I wanted to invoke M1 of parent class? So is that possible? How do I invoke? So using the object created by the child class, when we say M1, we know as M1 has been overridden by the child class, so this will be called. But I wanted to call M1 of parent class. So how do we do that? So that is all about super keyword, right? So we can use it, we can call the parent class variable, or we can access parent class variable or parent class immediate parent class method using super keyword. So let's see that with an example, then you will get it easily. I'll have a new class. I'll call my class name as animal. So this will be my parent class, and we'll have some variable here or string object. We'll have one method defined, and we'll just say animal makes this now. All right. Now we'll have one child class which is inheriting animal class. Extends animal. All right. So animal is one class which I'm calling it as my parent class, and dog is one child class which is extending animal class. All right. Now I wanted to override the color, so I can do something like this. So that this color, right? So which is already present in parent class. So we will get a copy of this, or this is visible. This is visible, right? So this is visible to dog class as well. But what we are doing, we are overriding that variable. We are overriding this variable, right? Or object called color. And let's say, for example, we have some method called display color here. Now, when I say color, we know what it prints, right? So display color, it is clear that it will actually display the color of child class because it has been overridden, right? So yeah, we can see an example on that as well. So say for example, okay, we don't have main method here. No worries. We'll define a new class and we'll have a main method there. So we'll call this as, we wanted to test super keyword, right? So test super. All right, now you can see we have an animal class, which is a parent class, and dog is a child class, right? So color is the variable or object which has been overridden here, and we wanted to understand this line now, right? So I'll have an object created for dog class and call it something like this, okay? And then we know when I call my dog dot display color, so what color it will pick? It has its own copy and as well as one color copy extended from animal class, right? So we know as this has been overridden, it takes the overridden methods implementation, right? So it has taken the color. So uh, this color object which has been overridden by the child class. So it is applicable not only to the methods but also to the variables as well, right? Now, I wanted to actually call, instead of this, I wanted to call the color of, I wanted to invoke or I wanted to access color of parent class. So by default, as we have overridden this string object in child class, we know that, so we access the child class object or child class variable, right? But intentionally, I wanted to invoke the parent class variable or parent class object, right? So how do we do that? Using the super keyword. So how do we do that? Super dot, it's very simple. Super dot color, which invokes the, you know, immediate immediate object or immediate variable of the parent, right? So it invokes a immediate parent class variable, so which has been invoked, which has been overridden in the child class, right? So this is about overriding the or we override the class variable, parent class variable in the child class. But still, if we wanted to access the parent class variable, we can use super keyword to access the class variable or class object of the parent class, right? So if you say only color, or if you directly access the class variable, then it will take the overridden one or the child class variable. But if you wanted to access the parent class variable, right? So in that case, we use a keyword called super. So that it will access the parent class. Now, if you observe, let's run this. And you can see it actually displays brown, meaning it is actually able to access the parent class variable. So this we can achieve using the super keyword. And we have to remember this is possible only, like super keyword is used to invoke only the immediate parent class variable. Immediate parent class. Immediate parent class here is animal, right? So it could have multiple levels as well, right? So I can have animal, dog, and puppy, and another multi-level, right? So, but this is only possible for the super keyword can only access the immediate parent. Immediate parent in the sense just one step or one level above it, right? So only it can access immediate parent class variable using the super keyword, right? This is about the super keyword accessing the class variables. Now let us see about the methods. You wanted to understand about the method, right? So we do have already some method called found, right? Okay, we'll override this method now. We'll say dog bar, right? And when we call found, so I have overridden this sound method here in my parent class. So and created an object of child class. So and then I'm calling the sound method. So which method it invokes? It invokes the child class method, right? We know that it invokes the child class method. All right. So, but I wanted to invoke this sound method of parent class. So how do we do that? Simple. So we just need to do super dot sound. That's it. So if you observe now, the animal makes a sound, dog barks, meaning it actually invoked the sound method of parent class. So we can see it here, right? And so as we called it within the method of sound, which is the child class method. So it is also executing the implementation of the child class method as well. So if you wanted this only to execute this sound method of parent class, then maybe you can define another method where we'll call only parent class method. And what we can do is we can call this method like this. In case if we wanted to access only parent class method, so this is how we can achieve it, right? Or else the usual practice is like we actually access the parent class method within the child class, because whenever we wanted to extend or provide some implementation or to the existing implementation, then we usually create a method like this, right? So we override the method. Then if you wanted to have the as an addition, then we can actually call the sound method, or call the method which is in parent, right? So using the super keyword. So it's simple. When we use super keyword, or when we wanted to access the parent class method, like how we were trying to access the parent class variable using super keyword. In the same way, when we wanted to access a method which is overridden in child class, but we wanted to access the method of parent class, right? So once it is overridden, and the child class object, when we wanted to call, it will always call the child class implementation, right? But when we wanted to call, in some cases, when we wanted to invoke the parent class method, we can use the super keyword, super dot method name. Then it actually calls the parent class method, right? Again, we have to remember it only invokes the immediate parent class method. Immediate parent class method that has been overridden, right? So sound is overridden here in child class, and its immediate parent is animal here. So only this method will be invoked using the super keyword. Now, how about the constructors? So say for example, I do have some constructor, some default constructor, right? I'll just call this as the default constructor. And let's have default constructor for dog as well, right? So where we'll say that this is the dog default constructor. So what is a constructor? Constructor will have the same name as constructor is also any like any other method, but it will have the same name as the class name, right? So you can see that's how it has been defined here. And the default constructor is which takes no parameters, right? So it is not taking any parameters. Now let us see how it works. So I'm creating an object right here. So when does constructor is invoked? Constructor is invoked during the object creation, right? So while creating the object itself, constructor gets invoked, right? Now let us see. So if you see, we got both. So even though we did not call the super keyword here, so when we actually create the object for the child class, what's happening here? So we know the default constructor will be invoked here, right? So constructors are invoked during object creation. And as we are not passing any arguments to this constructor now, so the default constructor of the child class will be called. All right. So it is here now. And it should actually display default dog default constructor called. But what happens here is, so as the child class is inheriting the parent class, so it will also have the parent class constructor as well. So parent class constructor method will be called first, and this is applicable only for the default constructor, right? Remember, and then the child class default constructor will be called. Because if you observe here, there is no overriding concept for the constructors, right? This is because overriding itself is like says it should have the same method signature, right? But constructors will have the method with constructors are also same as the any other method, but it will have the name of the class. So which is actually contradicting the concept of method overriding, right? But still what happens as we are extending the parent class, so we'll have the this constructor as well. We can invoke this constructor as well, parent class constructor as well. So this is the reason when we actually create the object for the child class, the parent class constructor will also be called. So in fact, it will be called first, and then the child class constructor will be called. So this is for the default constructor. This is for the default constructor. And say for example, I do have something called another constructor which takes a parameter, right? Now let us see how this works. So in the earlier case, we just created an object of the child class. And what happened? So during the object creation itself, constructor is invoked. And we do have, as we are extending parent class animal, so we do have the this default constructor of the parent class as well. So that's the reason this was called. This was called first, and then the default constructor of the child class has been called. So here, using super keyword like this. So we should invoke the constructor like this. The immediate parent class constructor, we have to invoke like this. So what we do for the class super dot, because that's a variable, we do super dot class variable name, right? If it is any other method, we do super dot that method name. But as it's a constructor, so it will have it. We don't need to specify the name for it, right? So it's a constructor. So we just specify super open brace and close brace, which it will understand that we are trying to call the constructor, right? So going back to the previous example itself, for the default constructor, how it works. So if you see the same output, meaning this is optional. This is default constructor and this is optional. It invokes parent class constructor. But this is like, even without this is optional. Even without using the super keyword, parent class constructor will be invoked. And this is only specific to the default constructor. Okay. And now, if you see here, why we said like it's only default constructor, you don't need to remember that. So we'll see that now. I have a method called animal, right? This is not a method, this is a constructor, right? Which takes one parameter. Now, I have another constructor defined in the child class, so which takes one parameter, right? Both are not same if you observe. The method names itself are different. So which means that this is not overriding, right? So now let's see. We'll have something written here saying this is dog constructor called. Okay. And we'll just say animal constructor called. All right. Now what we'll do is we'll create an object for the child class, or we'll create a new object. This time, it's not a default constructor. I wanted to pass some name here, right? Now let us see. So if you see here, it actually calls. So let's actually comment this out now for now. We'll create one object. And you see annual default constructor called, and also it's actually calling the constructor called, right? Because so when we call this method, so what happens? The default constructor of the parent class, which is already inherited, right? So that will be called. And also, as we are passing parameter, so this will be called. The dog, which is taking the child class method, which is taking one parameter, will be called. So that is straightforward, right? We can see it here. But the constructor is already there for the parent class, right? So it is already there. This and this constructors are also there in the child class. So the default constructor will be invoked. But if we wanted to invoke this constructor, which takes the parameter, so how do we do that? So what we need to do is super, because even without using the super keyword also, we can the default constructor of the parent class will be invoked. That we have seen in the last example, right? Now what we wanted to do, we wanted to call the parent class constructor with super keyword, but we wanted to call the specific constructor which takes the parameter. So in that case, we need to call the super keyword with the parameter. Now observe. So it will say animal constructor called. So then, body, big animal constructor called. So here it goes, and it actually calls this constructor, because here now we are passing the parameter to it. You can just consider super as like, parent class name itself, right? Parent class name itself. So animal of name, right? So this will be invoked. This is the reason you can see animal constructor called and body as well. So with these two, system.out.println that has been displayed, right? So you can just replace super with parent class name. So that will be easy to understand, right? Then dog constructor called. So this is how it works, right? So super keyword for constructors. Any questions? Is that clear? So let us summarize it. What did we do? Super keyword is used to invoke the immediate parent class, right? So it is used to invoke the immediate parent class variable that has been overridden in the child class. And how about the methods? So methods, so super keyword is used to invoke the immediate parent class method that has been overridden in the child class, right? And how about the constructor? Constructor is also same. Super keyword is used to invoke the immediate parent class constructor. So what do you mean by whenever we say immediate, right? So what do you mean by that is like I might have uh, okay, let me open this. I might have multi-level like this, right? So my parent class, this is child class, like this. I can have a number of classes, right? But what does this invoke? Say for example, this is C1, right? This is C2, C3 and C4, right? Now C4 is extending C3. When I call super here, so super like this, the constructor of C3 only will be called, right? So you have to remember that. That's what we call it as immediate parent, right? So when we call super here, so immediate parent of C3 will be called. That is only C2 constructor will be called. When we say super in C2, then only C1 constructor will be called, right? So that's how it works. That's what we mean by immediate parent, right? Same applies for the method and same applies for the variables as well, right? So this is what we need to understand. And this is all about the super keyword. So hope this is clear. All right. So I take that as yes, and it is clear. And now we'll see another keyword. So this is all about the super keyword, right? Simple. We can understand it like, so why super keyword has been introduced. So we had this method overriding concept where child class can override the parent class methods, right? So, and what is overriding? Having the same signature of the method. So, and if you wanted to put the specific implementation for the subclass, then we can do that, and that's called method overriding. That is what we learned as part of the method overriding. Now there was some problem, or there was some question, right? Like how do we invoke the parent class variable in that sense? Like whenever it is overridden, so if still we wanted to access the parent class variable, parent class method after overriding, how do we do that? Then came the super keyword. So just to solve that problem of accessing the immediate parent class variable or parent class method or parent class constructor, immediate parent class constructor. So in order to solve that, this super keyword has been introduced, and using the super keyword we can achieve, or we can invoke the immediate parent class stuff, right? So that's how you can easily remember. So if you don't wanted to use, you'll not use the super keyword. You'll get the child class implementation, right? But if you wanted to access the parent class, when this keyword is used, only when the overriding concept, during the overriding concept. If the method is not overridden, super keyword has no meaning itself, right? So this was introduced mainly for when during the overriding concept. When there is a overriding concept, and when we wanted to access the immediate parent class stuff, then we do use the super keyword. That's how you can easily remember, right? Now we'll understand about another keyword called final. There is a keyword called final. So we'll understand that now. So we'll understand final keyword with examples. So we can use final for variables, methods, and also classes. So I'll show you first for final variable. What is final? So say for example, I can have something like this. Class say for example, final demo, right? And say for example, I have something called double and then pi. What's the value of pi? 3.14142, approximately something like this, right? Okay, so we can define a variable like this, and we can have this as final. So when we do have this as final, we can't override this class variable, right? So child extends final demo, or if we can just call this as parent. This is child, right? Now I wanted to override this pi. Usually what we do, we provide some other value to it, right? Say for example, 3.123 or 3.788, something like that. But if you observe, so once we define it as final, then we do get this. Okay, it has to be, this is final, right? And when we override this, so this line actually causes the error, syntax error, saying that we can't actually override the final. So this we call it as class variable, which is final, right? So when we extend this, and when we actually write the try to override it, so the value, so we get the error. Just a minute. This is about overriding, right? So overriding it supports, but when we wanted to change the value, so change the value of the parent class variable. Say for example, this might actually confuse you, so let's take only this, like say for example, like this, and then I'll create an object. And then what we do is I'll access this final demo object, fd dot py equal to, say for example, I wanted to change the definition of it. This is not allowed. If you observe, so we get an error saying the final field, final demo dot pi, pi is pi. Pi cannot be assigned because remove final modifier of pi. It says clearly, right? So when we have a variable, so when we have declared the class variable as final, so that value can't be changed. So usually we use it for the to define the constant. The pi value is a constant, right? So no one should be able to change this value. So whenever we wanted to create an object for this class, and when we wanted to assign some other value to this variable called pi, right? So that is not possible because it has been declared final. So final variables, the values of the final variables can't be changed. So usually we create the variable, we declare the variables as final when we wanted to store the constant values. And whenever I wanted to have this pi, right? Say, for example, I wanted to calculate the area of circle, pi r square, pi, then I can use this variable. Instead of having this number, I can have something defined as double pi, and you can use this pi there while I wanted to calculate the area of a circle or perimeter of a circle, right? So in that case, we have the pi, then we can use this constant. So as this is a constant, this value should not be changed, right? So this value should not be changed by anyone else. So this is the reason we can declare it as final. Once we have the class variables as final, so the value of it can't be changed. As we can see here, we are getting an error. So when we try to actually try to modify the value of final, right? So it clearly says the final field cannot be assigned final demo.py because it has been declared as final. So this is not allowed. This is about the final variable, right? How about the final method? We'll see an example on final method. Say for example, let's create a class, new class. I'll call my class as final method. All right. For this, we'll create a simple class called bank account, and I'll have some variable called balance sheet. Okay, and we'll create a constructor. So if you remember, this is used to resolve the conflict between the local variable name and the actual class variable name, right? So we have a class called bank account, and we have a class variable balance, and we have created a constructor. Fine, right? Now, what I wanted to do is I wanted to have a method which returns double, and I wanted to calculate the interest. So this is my method, which actually takes rate of interest as a parameter. Say for example, something like this. Okay, and as this has to return the calculation of the interest. So how do we calculate this? We'll just multiply balance with the rate. So this is a simple method, right? Now I wanted to make this as final because I don't wanted this method to be overridden, right? Or I don't wanted this method to be overridden. So in this case, like I wanted to actually have that as final. So what I can do is, so first I'll show you without final. Okay. Say for example, we have a child class which extends a parent class. Where we are interested to have the, where we wanted to try to change the interest rate, right? So what I wanted to do here, I'll just say I wanted to override this method, class savings account. What happened? Add constructor. Okay, we can add the constructor. All right, we can add it, and even we can take the interest rate as well for this. I'll take one variable which is double, right? Interest rate, and we'll get this value here, super balance, and then interest rate equal to interest rate, right? So it's a simple class. You can see a parent class which has a one variable called balance and a constructor which is invoked to initialize this balance, and one method which actually calculates the interest. So we are going to pass to this method rate, and then it is going to return us the actual interest by calculating the interest, multiplying the rate with the balance. It is going to return us the interest, right? So there is another class, savings account class, which is a child class, right? Which is a child class and which is extending the bank account, which is a parent, right? And now we had some other variable here, and we just created a constructor here. So when we do super here, what happens? The parent class constructor will be invoked, and we are passing the balance to it, right? So this balance will be initialized. This till here we know everything, right? Now I wanted to override this method, calculate interest method, right? So I'll just take this copy and wanted to override this method. So how I wanted to override this method is, I just wanted to have it as calculated something like this, right? So written like this. So when we try to get, you can see here. What does this mean? So we have method here and we are overriding this. So what does that mean? We are overriding the method, right? So how I am overriding? I am providing a different implementation to this method in the child class. So this is possible. This we have seen, right? But this is, say for example, I wanted to protect this. I wanted none of or no one else to actually modify this implementation, which is different in the parent class. And whenever this class has been extended, this method, which is calculate interest, should not be modified. So I wanted to secure this method, not to override this, not to override this implementation. But any child class which is inheriting this parent class bank account can actually have provide its own implementation, right? So, but I wanted to restrict that. So in that case, we can use final to the method. So see, once I declare my method as final, in the parent class, the child class method, when I try to override that method, you can clearly see the error here. So it says cannot override the final method from bank account. So it's getting a direct error, right? Which clearly says that cannot override the final method from bank account, because this calculate interest method, which has been declared as final, and you are trying to override this method, which is not allowed. So we declare a method as final when we wanted to actually restrict the method from overriding. So at that time, we declare the method as final. This causes a compile time error. We can't override a final method. So this is an example of that. So I just gave you some, some close real-time example where we need to use the final, final to the methods, right? So where we wanted to actually fix the implementation of the method, right? And we don't wanted to have that method overridden. In that case, we can have our method defined as declared as final. Then in that case, any child class which is inheriting the parent class can actually inherit all the properties. Even this will be inherited, but there will be no method overriding. No method overriding will not be supported on the methods which are declared as final. Right? All right. So now we discussed about final variable, right? Final variable so once we declare a variable as final, so that can't be actually, we can't modify the value of a final class variable. So we usually use that for the constants. So for a constant, like by any other value to be stored, where we wanted to have only that value for that variable, right? And so that we call it as a constant. And in that case, we can declare our variable as final, that we have seen here, right? So in that case, like you can't modify the value for the constant or the final variable. So a variable which we wanted to make it a constant and have, and if we wanted to have the value to be used, and if we wanted to have that value to be never changed, then we declare that variable as final. We declare that variable as final, right? Now, and when we wanted to have, the method to be restricted or method to protect from method overriding, that method has, so we wanted that method not to override. In that case, we declare that method as final. So that methods which are declared as final can't be overridden. Now we'll see an example of final class. What is final class? Final class is again like uh, straightforward, right? So parent class, say for example, I have a class. called some vehicle. Say, for example, I have some method in it. I'll just say this is a vehicle. Right? So I have a vehicle class. Now, can I extend this class like this? I can do it, right? So we can extend this class. We see no issue here, right? So we can even have the something like this. We can declare a variable for the vehicle class and also can call the object method within that class. So this is fine, right? Now, when I wanted my class to be fixed, like I don't wanted this class to be extended by any other class, right? So I'll have this class defined, but I wanted to restrict this class not to inherit by any other subclass. So in that case, we declare this class as final. So as soon as I declare this class as final, we get an error here saying the type car cannot subclass the final class vehicle, right? So you can clearly see that the type car cannot subclass the final class vehicle because the class vehicle has been declared as final. So once you declare a class as final, so that class can't be inherited by any other class, right? So this is how do we make a class as final? We just need to add the final keyword before the class keyword, right? So which makes the class as final and that class can't be inherited by any class, right? So we are actually protecting that class, not to inherit, so that any other class can't inherit that class, right? So this is about the final class. So we have seen three now, like final variable, final method, and also final class, right? So final variable value, we cannot change the value for the final variable, and final method, we can't override the final method in the subclass, right? And class, so whenever a class is declared final, we can't extend the class. So this is all about final keyword. Is that clear? All right, so if it is clear, just to recap, so final variables value cannot be changed once it has been initialized, right? And this makes the variable a constant. And methods we can't override by the, so methods when we declare them as final, it can't be overridden. And this is useful when you want to ensure that the specific implementation of method is not changed. So we have specific method and we have implementation for that method in the parent class. And we wanted to make sure that implementation is never changed. Then we declare the method as final. And when do we declare a class as final? When we wanted to have this. So when we wanted a class to be, it should not be subclass, right? Or it should not be inherited by any class. Then we can declare a class as final. So this is useful when you wanted to prevent the inheritance and ensure that the class implementation remains unchanged, right? So when only then we declare the class as final, right? So till now, what did we discuss? We discussed like have multiple keywords, right? So let us recap them. We use this keyword, and this keyword is used to differentiate between a local variable and a class variable. So we use this keyword for the class variable, right? So when we use this keyword, so we can identify that's a class variable. And when do we use this keyword? When we do have the same name for the class variable and the local variable, and to differentiate that, we use this keyword for the class variables, right? And then we use static keyword, if you remember. So static is like if a method is static or if a class variable is static, so that is common for all the objects. So when we have a class variable or method in a class as static, then that's shared across all the objects, and we don't need to create the object to invoke those class variable or method which is static. We can directly use the class name to invoke it, as it is, as it will not, as it is not independent or specific to any object. It's common for all the objects. We can use the class name to invoke the static variable or static method. Then we learned super. We learned just now, like super, right? Few minutes back. So super keyword is used to invoke the immediate parent class stuff. So that's the use of super keyword. And we just now learned about the final. So final is used to restrict the mainly used to uh, for protecting the values. Like if you wanted to uh, have the constants, we can declare the variables as final, and methods to protect them from overriding, we can have the method as final, and to protect the class from inherited by any other subclass, we can have the class as final. So that's the use of final is what we learned, right? So these are the keywords which we learned so far. And coming to the OOP concepts, like we understood class and object. We started with class and object. We understood this, and then uh, we started with polymorphism. We completed encapsulation, and in the last session we discussed about inheritance, right? And also in this session we have seen a concept of inheritance called method overriding, right? So polymorphism, one thing taking many forms. Encapsulation is all about setters and getters, if you remember. It's like wrapping up of data, right? Or binding data and methods together. And what is inheritance? Inheritance is acquiring properties of parent class to child class, right? And there is one more concept called abstraction. So data abstraction, which is all about abstraction, right? Right, hiding the internal details uh, and showing only the functionality, right? So this we'll discuss in the next session. We'll discuss more about the interfaces also. So we said like multiple inheritance is not supported by Java using the classes, right? So that can be supported using interfaces. So we'll discuss that in the next session. So is that clear till now, this session? So next session, we are going to discuss the last concept of object-oriented programming, that's called abstraction. So is that clear till now, this session? If everything is clear, I can stop here. And if you have any questions, you can ask.